All right, so have a nice day, everyone. So, in this video, I will be going to give you a simple code that will perform a simple graph structure. So, let me go ahead and start then. So, have here a import java.util dot asterisk. And by the way, I use the asterisk just to include the data structures like hash map, array list, and everything. So that is a representation for a generalization. Now, um I have here a graph for a class representing an undirected graph. So I actually defined here a name graph that represent the undirected graph structure. Then I also created a private map initialization. I declare a private map called adjacency of list, and that uses a string as the key representing each of the vertices and a list of string as well, map of string and a list of string. So as the value for each map and each list, it will be a string. So in order for me to store the adjacency of the vertices, so that is actually the representing the string. So that represent the graph adjacency list in our graph here then. So the adjacency list store the graph. Now I have here a constructor that initializing the adjacency list, which I in the constructor of the graph I initialize the adjacency list right there as a new hash map, and that hash map will hold each of the vertices and its adjacent vertices. So if you can picture out in our structure in our discussion that adjacency list is a simple linked list. So in our hash map, we can also do that, particularly as we've also discussed in the previous discussion. After that, I have here method that adding a new vertex, which public void adding vertex, string vertex with then adjacent list, put if absent, vertex new array list. So that signifies defining there a method of add vertex that taking a string parameter vertex here. And I put here the put if absent that ensures a new vertex is only added to the adjacency list if it doesn't already exist. If there is no value or I mean adjacency right there yet. It associates the vertex with a new empty array list to hold any adjacency vertices. Now, after I have the method to add an indirect edge between the two vertices, which the public void add edge, then I have there the string src string dest. So that defines a method that adding edge or add edge that takes two string, which is the src or the source vertex, this one, and string dest, which is the destination vertex. So I separated the two. So that method adds an indirect edge by updating both vertices adjacency. So adjacency list that we are using right there. After that one, I have here adjacency list put if absent in our source, then new array list that ensures the source vertex exists. So that ensures the source vertex source in the adjacency list if our source is not present. So it's actually adding with an empty list. So it's added with an empty list right there. Now, I also do have adjacency list, put if absent, dest new array list, ensure destination vertex exists. So that ensures that the destination vertex, dest or destination exist in the adjacency list. If our desk is not present, so it's added with an empty list only, diba? Now, in the third line, adjacency list, get a source add desk. So that is adding the destination to the adjacency of list of the source, indicating a connection from the source to the desk. So they do have connection. So we are adding destination to source adjacency list. And after that one, I have the adjacency list, get destination, and that add source, which is adding source to destination adjacency list, which is undirected, or the add SRC to the adjacency list of dest here, making the edge undirected by connecting dest back to SRC. So they do have relationship to each other, vice versa. So if you can picture out in here, so that is representing the undirected graph. Now, method to display the graph adjacency list here, this one, which I am using the public void display, define method display to print each vertex and its adjacency vertex in the graph. So I have here the iteration. I use the for var entry, then adjacency list, enter set. So I also print out the vertex and print out the adjacent of that vertex. So that I am actually iterating here through each entry in the adjacency list. So in this one here, each entry represents a vertex and its list of adjacency vertex. So you can actually picture it out already. Now, after the entry, I print the vertex key of the entry here. So I print that out by having the indicating the connection. So, ano siya ang connection natin. And for var v, entry get value, that is a loop through each of the adjacency vertex, this one, which is v, in the list of the current vertex, and prints it separated by a space. So this one here. And I am just printing the adjacency vertices, which is I'm adding a new line after printing all adjacency vertices here of the current vertex to separate the output for each vertex. So that's why ginbutangan ko the spaces afterwards. May ari ko di to separate the output, or to separate na next line. Now, main class here to test the graph class. So those kind of functions that I've actually implemented above, I can call that here then. Now, I want to I just define the main class where we can test the graph class right now. So inside our main, I created a new graph instance named graph as well. So this one, I created a new graph. And in our add vertices right there, I call the add vertex. So if you will certainly see, I call that function. And after calls the add to add four vertices like the A, B, C, and D to the our graph. So in order for us to represent that one, since there is no adjacency for each other yet, so I actually call the edge. So for the edge, I call the edge function, this one here, in order for me to add edges between specific pairs or the adjacency between the two. So vertices creating an undirected graph. So here then, A is to B, and A is to C, and B is to C, and B is to D, and C is to D. So that it will also display the graph after by simply calling the graph display. I just display that afterwards. So the possible outcome, if you will picture out, so A is pointing to B and also pointing to C, So the adjacency list of A must be B and C, di ba? And since this is just talking to the adjacency list, so we are having that by the adjacency. So since we're calling the display here and we are pointing that out via their adjacency using the adjacency list. So now it must be printed that after your B here must be the edge of that, since B is to C and D and also A, so that must be A, C, D, di ba? A, then C and D. So for your C, the adjacency will be D, then B and A. So it must be BA and D, diba? And for your D, that will be C and B. So it's actually B and D. So let's try to run that one if the adjacency list will be correct. So this will be the adjacency for that. So this is actually simple representation using the adjacency list if we are plotting a simple graph for this data structure. So that's actually the end of this quick video, and I hope that you will study this one, since of course maybe I will also give you a short activity pertaining to this one. So thank you.